there's literally no human to click the consent button. So what was the agent actually succeeding at? Our criteria had assumed that OAuth would happen successfully because they were outcome-oriented, and so it was only looking at what the plausible outcome of the agent having actually interacted with the service that was doing OAuth would have looked like. And the agent knew enough about this service to plausibly hallucinate.
AI Native DevCon is back.
The leading event for engineers and organizations moving agentic development into production.
Join us on June 1st and 2nd at the Barbican in central London.
For 2 full days of workshops, fascinating talks, and great company.
You'll hear from some amazing speakers, such as Ryan Lopopolo from OpenAI, Dana Lawson, CTO at Netlify, Justin Cormack, the ex-CTO of Docker, and Birgitta Beckler from ThoughtWorks.
They'll join speakers from Anthropic, NVIDIA, GitHub, Cisco, Meta, Adobe, Mozilla, and many more.
This is a practitioner-led community event and would love to have you join us.
Head over to ainativedevcon.io to grab your ticket.
We'll see you there.
As Simon mentioned, I lead the AI engineering team here. We run a lot of evals. We've had a lot of pain running evals, and we've had a lot of learnings from those evals. So very happy to talk about anything that I chat about here in these slides afterwards or at any point. Also, all credit to Claude for the design of the slides. I'm a really bad designer, so the reason these look anything remotely to nice is because of Claude. Also, I know Simon said time for questions at the end. We will leave some time. If you do have any questions throughout the entire presentation, please feel free to stick your hand up, interrupt me. Happy to kind of take those as we go along. Cool. So basically what we've realized is that kind of a lot of the coding benchmarks that we got out there, SweBench, Terminal Bench, the leaderboards, all of those kind of things, they're great, but they're a single number, and they're a number that we've sort of stopped trusting a little bit because of all of the kind of other impacts to that number. So really what this talk is about is really trying to get at what those numbers actually are measuring, the ways that we can start to decompose that into signals that we can actually trust, and also the knowledge that we've learned that the numbers aren't really what we expect them to be, and that if we were just blindly optimizing for the benchmark number, if we're just benchmaxing, it's not going to get us the results that we wanted to. There are kind of 3 main traps that we kind of saw that we'll go through in sequence. Personally, I think they show up everywhere agentic evals are run, including at the labs. And it's not that evals are broken. I really don't want to claim that. We run far too many of them to be saying evals are broken. But it's more so that figuring out how to evaluate AI agents, that itself is a discipline. I don't think we figured that out yet as a research community. And so if we just treat it as cool, just run an eval, then you're going to be led down the wrong path. You actually need to think about what it is, what signal you are that you're measuring. So this is some numbers just from a run that we did last week. This is for the Kimi launch recently, so Kimi 2.5 and 2.6. We ran this on Kimi CLI backed by Kimi platform.kimi.ai, so the official Kimi platform. Same scenarios, same harness, same eval orchestrator, exact same everything. And we are seeing radically different failure rates. About 18 times higher failure rate for 2.6 than we saw for 2.5. This was kind of unexpected since, we think that 2.6 should be a better model. This would be a regression. This would be something bad that Kimi had shipped because it's showing up over a pretty wide diversity of evals. We run over 500 different skills and over 2,000 different scenarios kind of for our benchmark that we do on new model releases. So this would be at that point where I'm like, okay, what's going on here? When we started to dig into it, it wasn't Kimi, it was us, and it was specifically Daytona. That's what the container platform that we end up running our evals on. And it turned out Kimi 2.6, for whatever reason, when running the Kimi CLI, started using up a lot more memory on the box. And so we had to bump the memory resources on the box. We are OOMing kind of pretty consistently at a 3% rate. And we weren't capturing that and being able to debug that easily, but also that was showing up as failures because the way that we had constructed our eval harness was not something that had to deal with this. We have a headline number of, oh shoot, something is looking a lot worse than it looked before, for when we have kind of a strong prior that, hey, this should be a better model. It is a model bump. We'd expect the labs to be doing their due diligence and making sure that these are all better. So what I would claim is that every eval lives somewhere between kind of this axis of synthetic versus kind of real project. And there's kind of trade-offs that you're making across all of these, across this entire axis. Synthetic, those are the super easy ones. Like they're controlled, they're cheap, they're repeatable. You've got kind of a known state, you've got a known scenario, you've got a known fixture. It's pretty easy to do. The real ones are the ones that are a little bit more difficult because you're trying to do evals over something that changes in time. So if you're modeling evals over a repo, over a project, that project is going to accrue different patterns, different architecture, different features over time. And so you can't just run the same eval scenario that you had before on the repo in a new timestamp because, hey, the entire repo has changed. So we think the real project evals, they have a lot of value. They give you actual indication on what you as a software engineer feel when using a coding agent in your repo day to day. But it is a much harder state space to be modeling and a much harder eval to run versus the synthetic one, which might give you a bit of a fuzzier signal, but give you cheaper, you can run it more repeatedly. Think unit test versus integration or end-to-end test. One's expensive but stronger signal, one's cheaper but weaker signal. Where do you kind of make the trade-offs between the two? So the first kind of pillar that I wanted to talk about is what we've started to call kind of the outcome trap. It's kind of the easy thing to be measuring. It's, did the agent produce the correct code? Did the test pass if you're doing something that's kind of sweet bench kind of informed? Did the test complete? Did it do something? What we've realized is that's kind of like, that's the necessary condition, but it's not the sufficient condition. What we actually care about for a large number of things, particularly skills, is not what the agent did, but how the agent did it. It's the workflow that it followed. Did it read your security policy? Did it apply that? Did it make sure all your endpoints have the proper endpoint protection? Did it go check linear and update a linear ticket in order to make sure that it tracked its work? Did it file a PR? Did it do all of that stuff? And that's the stuff that we're seeing is encoded within skills. A lot of skills are workflows and workflow oriented in terms of a sequence of steps that you're meant to do, not your output code must look exactly like this. So this can mean that the model can take shortcuts that happen to work on this scenario, but won't necessarily generalize across other scenarios that are kind of out of what this scenario is evaluating. So what I would say is that if you're only going to measure kind of the final outcome, all of those ways of either guessing the correct answer or skipping a couple steps or kind of jumping to the conclusion, that looks like real success. And so you might ship a skill that you think is working, but it's actually not being loaded, it's not being used, it's not guiding the agent down the correct path because it just happens to be getting there. Mind you, that is a separate question also to understand in terms of if it's doing, if it is completing the task without your skill, is it actually valuable? That's in a different talk though. So for this one, this is one specific eval case that we had that was actually run by one of our researchers internally at Tessl, and it showed phenomenal improvements, 6.25x improvement from kind of the baseline case of no context to the experimental case of with context when we're kind of passing in the skill. It was pretty much the highest one that we'd ever seen repeated. And we started to dig into it and being like, cool, what is so awesome about this skill? We are first looking at the skill content and trying to understand, like, hey, is this skill content actually good? Is there something that we can learn or generalize from that? And then we started looking at the trajectories, and then we started looking at the scenario and the output. Turns out that the first step in this skill is OAuth. So you've got to OAuth against a external service, and then you can go follow the sequence of steps within that skill. We don't support OAuth in our sandboxes. We don't have that mechanism at the moment to be allowing your agents or whatever coding agent to go OAuth against a service that you haven't provided an API key or another mechanism to do authentication with. There's literally no human to click the consent button. So what was the agent actually succeeding at? Our criteria had assumed that OAuth would happen successfully because they were outcome oriented, and so it was only looking at what the plausible outcome of the agent having actually interacted with the service that was doing OAuth would have looked like. And the agent knew enough about the service to plausibly hallucinate, given the context of the skill, what an appropriate outcome would actually look like. So we started having to realize, like, hey, we need to start looking at trajectories. And so out of not just this, but a bunch of other kind of scenarios and findings we've had, and also the realization that, hey, workflows are actually what people are doing, that's really where we started to invest more heavily in terms of kind of doing criteria that aren't just tightly coupled to the actual outcome, but criteria that are also coupled to the trajectory. So being able to look at both of those dimensions so you can actually evaluate what kind of impact your skill has, rather than just the outcome of that skill. This is a fun gotcha. But it's also kind of one that we think is more around how we think about kind of framing evals and framing the approach to evals rather than something that we're going to have continuously. Now that we're looking at kind of trajectories, yeah, cool, we solved that one. We're going to be able to kind of support this moving forward. The one that I think we start to get into a little bit more, trouble is probably too strong a word, but is a little bit more difficult is also looking at judges. And so LLM as a judge, we love it, it's great. Being able to define rubrics and being able to have a bunch of LLMs go assess the quality of either a trajectory or an outcome based off that. It makes our lives a lot easier rather than going and hand grading a bunch of stuff. But this does raise a problem. One of the things that we started to notice is, yes, that there is there's kind of been some reports, some results reported in the literature around self-biasing of models in terms of, hey, you have a Sonnet model, grade a Sonnet solution, it's going to give it a higher score than if it's grading a GPT solution. What we also started to see is that those apply across model families as well. So Sonnet has a preference for GLM 5.1 for whatever reason that is much higher than the preference that GPT 5.5 shows for GLM 5.1 solutions. So it's not just you've got to make sure that you aren't just comparing within a model family, you've also got to understand what the cross-model family kind of bias is. And so that is one of the other kind of issues with this judging bit that we started to see. And so this actually comes from one of the results that Simon shared on the blog, I believe yesterday or today, very recently, that was looking at kind of, or soon, tomorrow. Okay, this will be shared tomorrow, that is looking at exactly this. So we had a bunch of scenarios. We thought they showed phenomenal, very interesting results where GPT 5.5 was actually worse than GPT 5.3 when we were being evaluating against one set of judges. Then we started to investigate and swapped in another set of judges, and then another set of judges. And then we started to see, okay, cool, this is really what a case is of this. It's a case of where there's some bias within a model family towards a certain kind of solution or a certain set of solutions. So it wasn't kind of like catastrophic. We're not going from 0 to 75 or 75 to 100 or something along those lines. But it does kind of shift directionally the rankings and shift kind of the results that you can infer from that. We want to mitigate this, though, because we use it a lot. As I mentioned, we're big on LLM as a judges. And we do think that this is something you can mitigate, though, by putting in place enough checks. Functionally, what we do is we run a lot of benchmarks. We really try to understand the biases that each of these families will have for either, as I said, other models within that family or other models across families. We also are building rubrics because we find that those help reduce the inherent variance within an eval. Once you've got kind of like an artifact, and yes, that artifact can be LLM generated, but that helps ground the kind of scores and ground the kind of results that you're getting. And we also start to averaging across different model families. Like, as with so many things, rather than just trying to get the one cherry-picked result that is great, run it a bunch of times, do the average, it starts to work out. I think the real big learning for us around this was it's not just averaging across the solutions. That was something that we've been doing from the start with recognition of the variance, particularly in a non-deterministic setting with an environment and code and all the kind of stuff that can go wrong there. We were always doing that kind of like run multiple solutions. It was we also need to run multiple judges and also need to apply that same kind of principle and that same kind of rigor to both sides of that equation. Finally, scale. So this is more on the infrastructure side, and this is more on the weird stuff happens when you're running at scale. And that basically just comes down to any distributed service. So super easy, super trivial when we're running kind of even 500 scenarios on a user's laptop. When someone on the research team is there to click the button and it calls running locally, that's a pretty good setting. We know the laptop's not going to go off. We know the laptop is going to be connected to our office Wi-Fi. It's strong, it's stable, all those kind of things. That's pretty repeatable. When we started to run these kind of 20,000 times, 30,000 times, 40,000 times across Daytona, across AWS, across all of our different infrastructure providers, and we then need to be kind of considering load balancing across Anthropic, across Bedrock, across Vertex because of the scale that our eval runs are, we start to see that, hey, misconfiguration, hey, those out-of-memory resource limits that I was talking about before actually start to not just cause failures, but start to cause differences in the scores that we're seeing. So things that kind of broke at this scale, Anthropic is the next slide, sorry. Things that broke at the scale, these are kind of like the super concrete stuff that is very top of my mind at the moment. There have been other issues in the past. One is stale Docker layers. This is the chronic issue in terms of versioning of software. I can't count the number of times that I've had the different version of Docker running in public or running on our cloud versus running locally on my machine. This is all stuff that as you mature, you build the processes and the checks and all that kind of stuff in place. But it's also stuff that makes versioning and keeping track of the metadata specifically so important. Because the number of times we've had, hey, cool, we've had a regression, oh no, Claude code just changed. That has also been higher than I would care to admit. In terms of concurrent sandbox accounting, cool, this is a specific work with Daytona, where it will tell us, hey, the sandbox is shutting down. It will ack that request that we've made, but the sandbox itself will then take a little bit longer to shut down. And we immediately go, cool, okay, we got an ack, sandbox is down, let's go spin another one up. No, now we've got 2 sandboxes when we were expecting 1 sandbox to be running, and we've used up all of our resource limits. Another one, in terms of 0-second hangs, we've had a couple things that just hang, like just don't work. Is that Daytona? Is that the CLI? Is that the underlying model? Never been a big enough issue to kind of go investigate, but been enough that we kind of need to go kick those boxes every once in a while. So there's kind of a retry and a refresh loop that is needed there in order to make sure that you're kind of not just wasting time and wasting compute. And then in terms of pod errors, yeah, we see basically this concept of like a bunch of tasks failing when we kind of have super strict resource requirements because, again, non-deterministic agents that are writing code, importing dependencies, loading up your system memory by doing really, really big VEMs or really, really big node modules, and then importing everything. And these, again, often show up as failures because your solution didn't complete, it didn't write out, or it didn't get fully to the end. But they're not. They're resource issues, and the model would have actually finished had it been given the opportunity to do so. This is the Anthropic slide that I was thinking of. So this is from results back in Anthropic published back in February that are basically what we saw just a couple months later because they're, as usual, leading the field. And so it's very similar to that kind of concept. It's like, cool, you've got a bunch of different resource configurations that you can give to an environment that are using to run terminal bench in their case. And just by changing the amount of resources that you're giving to that environment, you actually affect the model performance, and therefore you affect the reward signal that you can get from that performance in an RLVR setting. And so that's super important because this is now something that is not related to your model, not related to your agent harness, but is related to something external to that. So now you're not just trying to say, hey, I'm optimizing my model. It's, oh, cool, now I'm accidentally optimizing my model given the resource constraints that I've used for the environments that I'm running my evals in. That is a much fuzzier signal than kind of you would hope it to be. So what I would claim kind of overall is that if you've got kind of slow evals, slow comprehensive evals, kind of the ones on the left, the really nice ones, like those are great, but they're not actually something that you can really effectively learn from. These might be the real world projects that have time drift that you're kind of spinning up an entire ecosystem, like an entire dev ecosystem on a box, so you give the agent the most representative eval scenario, eval environment possible. But then you've got really hard kind of constraints in terms of getting that reward signal back when the eval takes 24 hours to run because it's complicated and difficult. On the other side, you've got the really narrow ones. These are the synthetic ones that we talked about. Those give you a cheaper, fuzzier reward signal, but they give it to you much quicker. And so where do you want to sit kind of along that line, along that axis, in terms of what is more valuable? Is it to get something that is a fuzzier approximation of reality, but quicker so that you can then optimize and train on that? Or does it get a better representation of reality, but it's slower, and so yes, you get better data, but it takes you longer to run kind of a reinforcement learning loop or to optimize your context or anything along those lines. And so I think kind of for me, sitting on this team, really the most interesting perspective is that, and I come from a software engineering background for context, is that eval infrastructure, like these annoying bits of dealing with out of memory, these annoying bits of looking at networking, these annoying bits of figuring out how our orchestrator works, that's just not software engineering platform investment, that's like research investment. That is the thing that we need to do in order to do research, because otherwise we are getting noisy signal and noisy data, and that affects the quality of the research that we got to do. And so it's not kind of this disjoint between, cool, the research investment is just on the eval design, or just on the criteria, or just on the environments. No, the research investment is just as much on the underlying infrastructure, because all of this is connected, and only by kind of making sure one is solid, making sure that pieces are solid, can you actually get the insights that you want. So there's another kind of learning from this, and that is really around decomposition. So for each of those three kind of traps, those three issues that I mentioned earlier, outcome, judge, scale, there's a decomposition element to it as well. So in terms of the outcome, the decomposition is going from just looking at the outcome to looking at each step that the agent takes to be more effectively able to measure the thing that you actually care about. In some cases, it's just the how, you don't care about how, sorry, it's just the what, it's not, you don't care about how you got there. In other cases, you don't care about the what, and it's just the how, and so you just want to look at that. Often, it's both. For the judge problem, we can decompose that into making sure that the judge is checking small verifiable claims rather than, hey, is quality good? Or hey, is this code correct? Or hey, is this code secure? The more work that you do in terms of defining that rubric at a sufficient granularity, the more the more agreement that you will see across different judges and different judging families. Yeah, Opus 4.7 is great because you can give it a shitty prompt and it will figure something out. But if you're able to kind of break that down and decompose it, you're going to get a lot more reliability out of it. And then on the scale, well, we want to be able to decompose something that we can run kind of fast and narrow for getting some of that signal, but we also want to keep that opportunity for being able to run that super slow, I shouldn't say super slow, it's not that slow, it's like a day, but take that, the opportunity for running that comprehensive one for the opportunities where it drives us the value. So it's really being able to understand the domain that we are optimizing against enough that we can pick and choose which signals are valuable at which point in that cycle. I would much rather run 100 unit tests than I would one end-to-end test if I can get 95% of the confidence from the unit testing than I would be from the end-to-end testing. So this is kind of where I'm getting to in terms of like what that bigger point is. And it's that we don't really know how to properly evaluate these because there are so many different moving parts of the system. We've gone from a world where the original evaluations on an LLM were give it some text and get some text back, and that's all you're evaluating. Now we've got environments, now we've got agent harnesses, now we've got external dependencies, now we've got the file system. Like there's so many things that could go wrong in this entire domain that are all gonna have an impact on it. And so how do we then start to think through as kind of a community in terms of figuring out which bits of that are important and how we are able to then evaluate and report on that? Because it doesn't matter to me if they tell me Claude Code with Opus 4.7 got score whatever on Terminal Bench, if I don't know the specific Claude Code version that score got, that score was run with, because it has shown that, hey, Claude Code changes the performance, or the resource configuration because I might be running on a smaller box and, hey, it can't actually write as much code. So the last thing that I kind of want to say is really what I've tried to kind of outline here is basically having an honest mental model of what your evals are and aren't telling you. Like, yes, having a single number, that's great. It gives you something to optimize against. And if that's what you need to kind of report out, then fine. I'm not against like having a single number. We do need to do some aggregation. We can't just say everything is multiple numbers or everything needs to be kind of broken down into smallest parts. But be honest kind of about what those individual bits are. And if it is something that infra is going to bite you, or if it is something where you're measuring kind of the fuzzy approximation because you're only looking at outcome and not the process, then yeah, that's fair. You don't need to measure everything, but be aware of where those blind spots are because you'll A, trust your evals a lot more when you're able to caveat them with kind of the incorrect bits or the parts that you don't know, and B, then hopefully be building in a way that you can start to mitigate that moving on. So that's pretty much it. I think Simon has a fun throwing mic for questions.
Yeah. Test, test, test. I was going to ask who's got a question for Rob and who's good at catching?
What if you're only good at one of those things?
So you mentioned that you need to run your eval fast. What kind of tools are your favorite in this situation?
So I talked a lot about Daytona and our frustrations with Daytona, but I love Daytona for that reason. So basically, we have invested a fair amount in our own custom eval orchestrator, but it is all running on Daytona as kind of our compute platform because of kind of sub-second startup times. And when we want to spin up a whole bunch of eval containers, that really helps. We haven't invested significantly in terms of like actually tuning the eval environments themselves because we'd rather parallelize out across environments and cross scenarios than kind of speeding up any single run. So I think our stack kind of biases a little bit towards do a lot of things in parallel rather than do any specific things super fast. The implication of that, though, is that we then try to make our eval scenarios kind of as small as possible in order to get the signal that we want, rather than having kind of a bigger, complex scenario that might be measuring multiple things that take a longer time, but then we can at least run them in parallel.
Time for one or two questions. One.
Potentially controversial question. Do you really need to evaluate for processes, or can you evaluate by outcomes but using a large range of more representative data that's been designed to trigger failure modes at each of your processes?
Possibly. So, sorry, the reason I'm hesitating there is just kind of thinking through how, for some of the failure cases that we've seen where we've needed to reach for the trajectory, if we would have been able to construct a scenario or construct an outcome that would have triggered that. Maybe, I think you can probably artificially construct enough scenarios that would cause a failure for any single step of the process. But the fact that it is taking me struggling a little bit to kind of think through what that process would look like makes me want to reach for kind of like looking at the trajectory itself. It kind of, in my mind, fits a bit more naturally in terms of like, hey, you're asking the agent to go do a sequence of steps. Go look at whether it did the sequence of steps, not whether you can create the scenario to have the outcome that would then imply it had the sequence of steps associated with it. So I think it's possible. I don't know if it's easier though. Yeah.
I'm going to ask, actually, there's really not time for one more question, but I will take one more question because I'll ask Dom to come up just to set up his laptop. And while that happens, we'll take a third question. Oh, no one further? I really want to throw it properly. I'm going to sorry, Manny, I want to throw it.
Hi. In terms of, you said you've got a quick set, like a unit test equivalent. How many evals are you running then, and how long do they take? You know, how quick is quick?
Yeah. So any single scenario will take between kind of 10 and 15 minutes. And then we try to parallelize across that as much as we want, or as much as we can. So kind of like our benchmark suite for any new model is we've got 500 skills that we think are a fairly representative sample of a bunch of different skills out there. And then those decompose into 5,000-ish different scenarios. And so that will be kind of the set that we run over new models. So running wall clock time on that is an hour because we don't kind of do it entirely in parallel, just we don't feel the need to. An hour is a quick enough time for us to turn around. We have explored doing regression testing on kind of our product on PRs. We didn't end up going for that because that ended up being about 15 minutes and that was felt as too long. But we have looked more seriously at is kind of doing that on a nightly basis because then we can do kind of like the full suite for an hour overnight and at least being able to assess that. So not quite unit test time, would love to be able to get down to unit test human in the loop time, but enough that it's PR review time, which is kind of the metric that we try to optimize for.
Thank you very much, Rob. Please give it up for Rob.